Hello and welcome everybody to our webinar today. The topic is detection of DC insulation faults. I'm very pleased to present you within the next 30 minutes the probably most difficult and also a failure which happens quite often if you have any DC isolation fault. My name is Hans Pilzer. I'm doing this presentation now for about 20 to 30 minutes. And I have also David Sandic beside me, who is in the chat. He will answer your questions during the presentation, so feel free to send your questions and we will answer that immediately. The agenda for this webinar is that we would like to start first with some general information about DC insulation faults or errors, then how to detect them or how we detect them in the inverter. Then finally, the troubleshooting, what you can do to solve the problem, and of course, as well, the replacement of components if needed. Before I start, I would like to have a short question to you. And I would like to ask you, did you ever have issues with insulation errors? Maybe first one, please click on the answer which suits to you. Yes, I've received but only state code so far. Did you ever try to solve them but without success, or finally with success? And last question answer would be you're only testing PV system after the commissioning. You do the grounding resistance check, and maybe this could be the last answer. So you can also answer more if more suits to you. But I would like just to get a short, quick overview. What's your main, what's your situation at the moment? Good. I get already some feedback. Please click on the correct answers. Yes, and so far I think I can close that now. That most of the people has already found the problem, and also a quite high percentage is only testing the system, including resistance measurement. So good, that sounds perfect, because then you are already, it seems that you're already quite good experienced with this topic. Good, I would like to first explain what's a DC insulation fault. Basically a short circuit or grounding resistance from the ground to plus and minus from the DC side. The possible causes are first the cable insulation, if there is any problem with the cable insulation of the DC cables, if it's the PV module itself which is faulty, the DC combiner box or the ESPDs, and finally, of course, the inverter, which can cause the problem. So we have more or less 4 different causes, and the detection with the ISO measurement in the inverter is necessary because first of the requirements of standard, and second, we need to protect the inverter because it's a transformerless inverter, and the transformerless inverter, if there's any short circuit from plus or minus pole to ground, would of course not work. And if this happens during operation, it can also destroy the inverter. Basically, also important to know that the grounding resistor is added, and actually we have a summary of the different resistances of the module, DC cable, and so on. So basically, we end up in a smaller resistance if we see the total resistance. So that's also good to know. So always look on the total system. If you check only one part, it would be possibly, if you check, for example, only the module, it would be not enough, because we need always to see the whole picture. Now, the protection of the inverter. The inverters are measuring the DC leakage current before starting up. Basically, this will happen in the morning, and we check plus and minus to ground. If the resistance is below 100 kilo ohm, the inverter will not start and shows a state code. For large system, the ISO resistance could also be adjusted in the web interface of the inverter and could be lowered down to a minimum of 34 kilo ohm. This is possibly necessary for very large installations, rooftop installations, where you have the modules flat on the roof, for example, a metal roof, where you will see that this 100 kilo ohm is probably not good, so you will have a smaller resistance. So, yes, and I already told you, when there is a ground fault, this can also cause a damage of the power stack of the inverter. So, and this would be also not a warranty case. So take care that you, when you do the DC cable wiring, take care that you do it correct and do it in a proper way. Otherwise, you could destroy the inverter. Basically, of course, the inverter before it starts would detect that, but if it happens during operation, it would cause a power stack damage. Now, if we look at the requirements of standards, it says that the international norm, IC norm, says that we have to interrupt the inverter, the operation, if a residual current smaller or higher than 300 milliampere appears, or there is a sudden change in the current, in the leakage current or in the residual current. We need also to interrupt operation. And here are also the sudden changes. So if it changes by 150 milliamps in a very short moment, we need also to detect that and react on that. So there is a slow testing on the one hand side of the residual current, and on the other hand also a fast measurement in the inverter which detects both values. And the inverter state code showing the fault, the RCMU in the inverter interrupts the operation of the inverter if this residual current is higher than 300 milliamp for a few seconds. Good. How we can see that now in the web interface of the Gen 24 inverter, we can see under advanced the insulation resistance, and it's shown here, for example, 4.99 mega ohm. In the list down below, you will see this value. So this is the slow testing of the grounding resistance, and of course you can also see that value as a true value, but not with the short testing, short measurement, which is, of course, can be different. The state code which appears is the state code 1078, and this is the state code which turns off the inverter. After that, the inverter will try again after a while and be reactivated automatically. That means so the inverter will try to start again after a few minutes, and then probably the problem is solved and the inverter can run. So that is, of course, also different. Same for Tauro inverters. For the snap inverters, we have some different state codes. The state codes 401, 447, especially insulation fault, 475, insulation resistance too low. This is an error. And 502 is just a warning that the insulation resistance is low. So basically, you need to react if the 475 appears or 447 appears. You can also read out the grounding resistance on the display under readings. You will find the value PV ISO. So this is the value in mega ohm. It's also shown here on the display of the snap inverter. Now, if you have a problem, so the resistance is below this value, the certain values, roughly we can say if the value is below 2 mega ohm, I would take care, because there is probably really a problem. If it's above 2 mega ohm, you can say, okay, depending on the system size, this is quite okay. Usually the resistance between plus and minus and ground should be much higher than 10 mega ohm. If you first detect, okay, you have this state code coming, appears, first have a look on the Solar.web, see if the production is still running, if the inverter is producing, and then under service messages, you can see the state code, and you can also see then the description here. So also this would be shown what to do, or what if this problem is an resistance, insulation resistance fault, then you would also see that here in the list what to do. So basically, if the inverter is not running and you see this error state code coming, then you need to go on site. And first thing you need to do is switch off the DC switch on the inverter, and open the housing, of course, and then make the voltage measurement. Best in this case, I would also recommend to disconnect the DC cable, or on the Gen 24, you can just remove the Vago clamp and measure between plus and ground and minus and ground. And there should be a voltage which goes down to 0 after a few seconds. So it will first detect a certain voltage, half of the DC voltage, and then this voltage would go down. Show you more about this on the next slide. So this is always the first test I would do. I would recommend. The second test is the ISO measurement with a PV tester. So you connect here, like we've shown here, our DC connector kit, for example, with the PV tester, and you do the ISO measurement to ground. So that's the second test. If you don't have a PV tester, you can also use your multimeter with a mega ohm meter. You can also check the ground, the voltage or the resistance to ground. But therefore you need to make a short circuit between plus and minus, and therefore you need a switch with which you can do this, of course, to disconnect, to connect first plus and minus, and then to disconnect as well. So therefore, probably you have already equipment for that. The string per string should be, as mentioned here again, higher resistance than 2 mega ohm per string. Yes, now more detailed, the voltage measuring method. Voltage measuring method, you measure between plus and ground and minus and ground the voltage. So when the DC side is disconnected. So you switch off, disconnect the DC Vago clamps, connect your voltage measurement on the plus and the minus pole against the ground, and check the voltage. You see the voltage will first have show the half of the DC voltage, and then go down within a few seconds down to 0. It's going slower and slower finally, but if you see that the voltage goes down to 0, then it is correct, there's no problem. If the voltage stays on a higher level, you will see immediately that there's something wrong. The other thing with the PV tester is really recommended, because here we can test the system with 1000 volt. I switch off the DC as well, disconnect the DC connector kit, and check the voltage here against ground with the ISO tester. Same procedure, of course, with all strings have to be done. All the measuring with the mega ohm meter, as shown before. Here you just need, as I explained before, a switch to make a short circuit between plus and minus. So maybe you have your equipment for that, then you can do that as well. Then you just check from the plus or minus pole then to ground, and you should have as well here the high resistance of 2 mega ohm. So, and same procedure with all strings. What's also recommended here is basically that you should probably do this measurement on a rainy conditions. So don't do it on a dry, sunny day, because that's probably not the problem where you have the problem that often. So it should also be high resistance at a rainy day. We have also some experience from practice, which I would like to share with you. First, the ingress of moisture in the modules. This is something which can also be shown only on a rainy day. So therefore, please do the measurement on a rainy day. Cable ducts expand due to heat. So the cable reserve is not enough. If you have too short cables, it can also happen that this happens with high temperatures or with wind and storms, where the cables only move to a certain position when there is a high temperature or wind. So therefore, also take into account that this could change, and check the wiring of the cable. Give enough space for the wires to have enough cable length. And last but not least, the inadequate laying of the cables, metal shavings, screws, or other conductive parts between the DC cables can also cause troubles. So this can happen sometimes only at a certain moment and then disappear again. So also this has to be checked, and take care that you have here done your job really properly, that there is no metal shavings and screws and other things in close to the DC cables. Also, of course, the MC4 plugs is a very, very often problem. MC4 plugs in the rain, in the water, laying down to the ground in the water, then of course you would also have probably this issue. So the visual inspection and detection of possible defects is absolutely necessary. And keep in mind always the overall systems from the module to the inverter. Please also check all parts. Good. And then finally, if we come to the service of the inverter, you could do some changes on the settings. Basically, when you go on the Gen and Tauro to the web interface, you will find under Safety and Grid Regulations the point Safety, and there is the isolation monitoring resistance, and this is adjusted to 100 kilo ohm. You could change it on a bigger system to probably 34 kilo ohms. Therefore, you just need to get our Profi password to enter into this setting. And first take care that you have done all the tests, the visual tests, and all the cabling is correct. Then this should be only the last step whenever you see you have a big systems and there's no other way to solve the problem. Same can be done as well on the step inverters, also on the Profi settings. Yes, if you have an error on the on the inverter, you should of course use our SOS tool and do the troubleshooting with that, and also then order probably a new inverter, replacement inverter, or replacement power stack. Just enter the state and the serial number of the inverter and the state code, and then you will get a guideline what to do, how to solve the problem, and finally, if there is really a problem with the inverter, order a replacement inverter, and you will sort out the problem in this moment. Yes, the summary, to sum up again, finally, first, check the state code. If the state code appears very often, make an on-site first voltage measurement. So check the voltage between plus and ground and minus and ground. Maybe do that on a rainy day, because that can be different. And then use your PV ISO tester with the DC inspection kit. Connect that to the strings and test every string with the ISO tester. If you have detected the string which has the problem, check the cabling and the modules of the string, check the inverter, and check the combiner boxes. So basically, all in all, total, you will see then probably where the error comes from, and then you can solve the problem. Of course, sometimes this can be quite hard work. So it can be really, for a bigger system, can be really hard work to find the problem. So it can take more time, as you probably have thought. But yeah, therefore we can only recommend you again, do a proper installation of the system. Proper installation will have no problems usually in the future. But if you do that maybe improper or not correct, then you could, of course, cause more problems in the future. For more information now, we have a document included now. You can find that on the documents here in this webinar. Feel free to use it, download it from here, and then you can get more information about this as well. Also on our webpage, you will find more information. Yes, don't forget our trainings and YouTube how-to videos where we show as well all the settings of the inverter and commissioning and so on of our components. Good. Then I would say I would finally ask now David if we have received any questions. David, did we get any questions?
Hans, thank you. Thank you for the very interesting slides. For now, there are no questions in the chat, but I would suggest that we stay in the chat. If there comes something up, we will be there.
Yes, exactly, we do so. Good, thank you, David. Then feel free to use the time next 5 minutes to send your questions, and we will answer that in the next minutes. If not, if everything was clear, I would thank you for your participation and wish you a good day and good luck for your next installations and next insulation tests. Thank you very much, and bye-bye.